Hello guys, nice to see you again. To this session about building your own JDK in 10 steps. Now, just before we start, I would like to apologize because when I submitted the talk, of course the talk was not quite ready yet, and I didn't have a very precise count of how many steps it takes to build your own JDK. So maybe in the end you will have a little more or a little less. So, well, just this disclaimer before we start. So the first thing we could ask ourselves is the following: why would you be wanting to build your own JDK? The JDK is freely available. You can download binary versions of it on GitHub, on the OpenJDK from other vendors. There's no problem with that. So, I mean, what's the deal? What value is there in trying to build your own JDK? I would say first reason is just for the fun of it. I remember when I was slightly younger, I spent some time trying to build Emacs or to build JCC, which were really completely useless to do because the binary versions were also available. I would say that building your own JDK is just about, yeah, I did it. I made it. Even if it's much more simple to do it now than it used to be in the past. Probably in the past it was next to impossible unless you were, of course, part of the JDK team yourself. You can also build JDKs that do not exist yet and that will probably never exist. This morning with Remy, we spent a deep dive session showing you new features, things that are not integrated in the mainstream, in the official JDK yet. So if you want to test those features, the records, the pattern matching, all things in the Valhalla, in the Ember, in the Panama project, well, you can just take the branches of code, build this code yourself, and try it, and see if it works, and experiment it, just like this. So you can build those non-existing JDK, and probably JDK also that will never exist. That is, since you are taking branches with upcoming features, those features will most likely change when you're between the time you build them and the time it will make it to the JDK itself. And by the way, you could ask yourself, are they really JDKs? Because for a distribution to be called JDK, it has to pass something called the Test Compatibility Kit. And this TCK, there is a license on this TCK. If you want to use it, you'll have to buy the license, probably. And running the TCK on a built JDK is certainly not an easy stuff. The London Jug has set up a project called Adopt OpenJDK that does that, takes the JDK and the TCK and build their own distributions. But this is not something you can do on your own. And when you download a branch of the JDK, let's suppose the Loom branch or the Ember branch, there is no TCK for this branch, just because it's not something that is in the official JDK, in the only JDK. So there's no TCK for this branch. So in fact, what you build is not a JDK. It's just something that looks like the JDK, but it's not the JDK. But we will continue to call it a JDK anyway, with this precaution taken before that. In fact, you have to do everything yourself. That is downloading the code, choosing your branch. And if you want to know what's on the branch, you need to check the mailing list and stuff because documentation is not there, since those are just features on the work. And if you want a JDK, custom-made JDK, you don't necessarily have to do it yourself, in fact, because there are already people doing that on the web. Let me just show you this repository. Just want to make sure that this is the one I'm talking about. Yes, this is the Java-Net Next repository available on GitHub, made available by Remy Forax, who is co-speaker with me this morning. And in fact, he set up some kind of automated stuff. It's just a plain Travis YAML script that downloads, that pulls the branches he wants to build, and that launches the builds on the Travis infrastructure every week or so, and makes the result available for you to download on GitHub. So even if you want to test the preview features of non-existing JDK and you don't feel like building it yourself, you can do that by just pulling this repository directly. And if you want a JDK that is not distributed in the mainstream, you can also go to the OpenJDK GitHub repository, where some of the branches are mirrored from the Mercurial repository. The official branches of the official JDK first, but also some projects, including the Loom project, have moved their work from the Mercurial repository to the GitHub repository. It does not mean that the Mercurial repository on which all the developments of the JDK take place currently is going to be closed anytime soon. Probably will never be closed because there are many documentation and stuff that points to the special commits of this Mercurial repository, and people don't want to break all those pointers, of course. So that's it. Why building your own JDK? You have many reasons not to do it. So if you still want to do it, well, you can stay there, and I'm going to show you how it works. This is the goal of this Tools in Action. By the way, Tools in Action is supposedly mostly live coding. I'm sorry, but you won't have much live coding because most of the live coding is about waiting for the code to be downloaded, waiting for the code to be compiled, waiting for all the elements on your Linux box to be downloaded, and you don't want to see that, of course. So I'm just going to show you the results, step by steps on the results. So the root directory you want to visit is this one. It's a Mercurial repository. Now, Mercurial is not exactly the same as GitHub. Well, it's different from GitHub, obviously, but it kind of works the same. If you have a good knowledge of GitHub, you won't be lost in Mercurial. Basically, it's the same concepts with different syntax. And behind the curtain, it also works differently. You have all the projects of the OpenJDK available there. There are at least 65 of them. That's quite a lot. So you need to pick the one you want to follow, of course. All those projects are not merged together, right? So if you are interested in the record, you will download the repository with the records. And on this repository, you will not have the stuff with Valhalla, for instance, because those are different repositories, of course. You have all of them. As I told you, what you're developing is not the JDK, so you will not download the TCK, and you will not run the TCK neither for licensing reasons. So what you're doing is really something that you can use on your own for your own testing and your own experimentations, but you can't redistribute it because you're not allowed to do that. If you want to have a real JDK, you can point to the Adopt OpenJDK project backed by the London JUG. Or at least it was launched by the London JUG. Here is the link. And on their page, the last time I checked, there were a bunch of JDKs distributed, 12 platforms, 6 versions, and 2 JVMs, Hotspot and OpenJ9, which is now part of the Apache Foundation. All right. So the starting point is really the basic point you can use if you're not an alpha geek with your own Linux distribution, homemade, etc. I just started with the standard Ubuntu desktop distribution. It's probably one of the simplest Linux distribution you can find. And if you start on that, the first hurdle you stumble upon is that Mercurial is not installed by default on this distribution. So you need to get that. All right. If you just type in the command that the OpenJDK says you, hey, if you want the source code, just type this command. Yes, you can do that. But before that, you need to install Mercurial. Okay, it's not a big deal, but you still need to do it. And once you've done that, you need to choose from the branches available on the OpenJDK. So here is the branch for Valhalla, for instance, for Valhalla repository. All right, so you have a set of sub-branches of the Valhalla project there. If you want to know what's on what branch, you need to check the mailing list to know what people are doing on it and what is the advancement of the project. Here is another example for the Amber project. Valhalla is about inline classes, the classes that are going to be laid out nicely in the memory. Amber is about adding some new syntax to the Java language. We have the switch syntax, we have the records, we have the smart instance of, and in the end we will have the pattern matching. Pattern matching is developed as part of the Valhalla project. And the third project I want to talk about is the Loom project. Loom project is a new model of concurrent programming in the JDK. It's actively developed currently. So if we visit this Loom branch, for instance, you will have a set of you could call that commits, right? Of elements, of activity on the repository itself, so that you can choose what you want to do. So let us suppose that we want to check out this Loom project to build it. So basically, to know what to check out, you need to take the name of the project and the name of the branch and type in hg-clone once you've installed, of course, Mercurial on your box. And this is going to take a while for several reasons. People are saying that the Mercurial repository of the OpenJDK is a bit slow. It may be the case, but in the end, you will have something that is going to look like this. And if you download the Loom branch and the Valhalla branch, for instance, and check for the amount of source code that you've downloaded, you'll find that you are basically downloading 2.5 gigabytes of source code for each branch. So if you don't have a high-speed internet, I mean really high-speed, it may take a while to download that. So just, well, have that somewhere in your mind. You can't just do that over your coffee break, for instance. It will not be enough. So once you've downloaded that, so you have the source code, you need to find your branch. And to do that, you need to check, to compare the hash code of the branch, the hash of the branch you have on the website, with the hash of the branch you have downloaded. And here, for instance, the hashes are not the same, so you need to update your repository. You have that with the hg branches command from Mercurial. So you need to update your branches, which you can do using hg pull. Yeah, so it's going to pull the default. Of course, once you've downloaded the 2.5 gigabytes, the diff that you need to download is much smaller, so it should be much faster to get everything. So this is going to synchronize your local repository with the remote repository of Mercurial. And here in another example for the Ember repository here. So now for the Ember repository, if you what you want to build, for instance, is the ember-demo-ii branch, you just need to switch to that branch, which is just ag plus the name of the branch. And then it will activate all the elements of that branch in your directory directly from your local repository, Mercurial repository, which is exactly what you want. And then you're ready to start the compilation. So you've already worked like maybe 20, 30 minutes if you are on high-speed internet to download everything and to set up everything. And now is the second part. It's not very hard. It's just that you need to run this script configure because it's not a Maven file, right? It's C++ compilation. So you first need to run configure, and unfortunately configure is not present by default in the Ubuntu installation. So you need to install it, which is not a big deal. So you run configure again, and then it tells you that it needs make, right? Yes, you're down. Make is still the standard tool. It used to be the standard tool to build Java projects, but it's not anymore. So now you need to install make. And then you run configure again. Now you have make, but you need a bunch of stuff to compile C and C++ code. And build essential, well, build essential could contain make, but apparently it doesn't. That's Ubuntu stuff. So you're good to download some more 100 megabytes. You've already downloaded 2.5 gigabytes. Okay, so one more megabyte is just trivial, right? You can do that very easily. And you think, okay, now it should be good to compile my stuff. But quite not. You now need the X11 libraries. Even if you're building something that is not going to use any kind of graphics, remember that you have swing in the JDK. So yes, you need to link that kind of thing with X11. That's 20 more megabytes. And now you say, all right, I think I should have everything. Almost. You still need what's that? I can't even remember. Sorry. Libcups. What is it for? Oh, yeah, printer. You're right. Yes. Yeah. Okay. Suppose you want to print something with your Ember branch, you'll need that. And then once you have the graphics and the printer, you also need the audio, the sound. Right? And once you've done that, you're good to go. So you can just grab the slide and just apt-get install everything in the first way. You don't need to try and fail everything, which is probably the point of, of this talk, having this stuff. And so now you launch configure, and at the end of it, configure will tell you, I could configure all the make files you need to compile your project. Now you may think, oh, thinks it worked, it probably did compile something. The answer is no. Configure does not compile anything. Configure just configures the compilation. So it runs quite fast. It takes maybe 1 minute or two on this tree of source code. And after this 1 minute or two, you're ready to launch the compilation itself, which is awesome. So the right thing to launch is make images. Make images is going to create a JDK image from the source tree. Remember, you have 2.5 gigabytes of source code, so it's not going to take like 2 minutes. It takes a little longer than that. I would say that on a fairly recent machine, it will take between 20-25 minutes, maybe more. It depends on your CPU. It also depends on the speed of your hard drive. If you're on SSD, it will be much faster than a classical hard drive because there are lots of input-output in this compilation. And if you say, okay, I'm going to do something else with my machine, well, you could, but it still use a fair amount of resources from your machine. So I was running that in a virtual machine, so I could keep some of my CPUs to do something else on the host operating system. But if you do that on a Linux machine that is going to do only that, it would probably be very busy for the time of the compilation. So that's another, let's say, less than 30 minutes, between 20 and 30 minutes compilation. And at the end of it, you will have this message, finish building target images, which means that everything is okay, and you have compiled your own JDK. And then you can celebrate, have a coffee, have a glass of water, something like that. I must say that it was, once everything was configured, it was really straightforward. The compilation really works very well, and there was no error, no warning whatsoever. So congratulations to the people who set all that up and to make it work. You need a fair amount of disk space to do this compilation, because if you check the amount of data you have in the directory, remember you downloaded 2.5 gigabytes of elements to launch the compilation. Once this is done, you have between 6 and 6.5 gigabytes of stuff in each of the repositories. So if you want to build, let's say, 3 branches, you'll probably need the 20 gigabytes drive to store all the information, which is, well, a fair amount of elements. If you need to know that in advance, because if you want to, if you take your default Ubuntu in some kind of virtual host, or the virtual box or whatsoever, the default size of the drive that is going to be created by the virtual software you're going to use will be probably too small to store all this. So you just need to think in advance that you need this amount of space. So now this is all fine. And the question is, this is the directory tree that is going to be created for you. And the question you ask yourself is, where is the result of this compilation? It's kind of hidden. Be careful, because you have a JDK repository there, and it's not here. So this was my first mistake when I tried to use it. It's in fact in server release. So this is the server release directory, images, and you have a JDK directory in this images subdirectory. And the result of the compilation is in that directory. And this is really a regular JDK. So if you want to use it, all you have to do is create a JavaOne variable, sorry. Export the path so that you can just run the Java, Javac, and all the tools you have in the bin directory of this Java home directory. And that's it. This is something I just created before September. But if you, I should be able to show you something. This is a Ubuntu virtual machine that basically did all the stuff that I showed you in the slides. So here I just prepared a Javac. Is it big enough? Yes, I think it's big enough. A Javac. So, oops, what did I do? Yes, Javac-version. So it's a Javac 14-Amber. The Amber branch currently is almost ready to be pushed as a preview release in the JDK. So it has changed a little. It doesn't have this weird version number it used to have a few months ago. And if I do the same with the Java version, it tells me that yes, it's you have a bunch of more information in the version number. So this is a 14 version that does not exist. So 14 version -Amber. So it has nothing to do with the 14 version early access that you can download directly from the JDK. All right, and we are going to I'm going to show you some features of Ambers. So this is a point class, by the way. I hope you can see it clearly. This is a point class, which is a record. So it's the new syntax to create record. You just create record by declaring the fields of the record. This record is built on int x, int y. And if I compile this record, I'm going to compile all the .java classes that are here. Oh, it doesn't work. Great, I love this. What did I do? Oh yeah, sorry. If you want to compile that, you cannot use Javac and Java. What you need to do is to compile using enable preview and to specify the level of the source code you have. Because this branch is, once again, it's almost ready to be incorporated as a preview in the main JDK branch. So this has been added. But if you try with Valhalla, for instance, you don't have to add those two flags. So I'm going to run again the compilation. That is going to work. I'm going to show you the main, I don't want to do that. Yes, the main Java code. Here I've got a first. Yes, I'm using Emacs to run the code and to compile and to show you everything, because of course Eclipse is not going to be very happy with this kind of syntax. So if you're okay to use Eclipse and to have a bunch of compiler error all over the place and that you can live with it, you can use Eclipse. But if you're not comfortable with that, then you should stick to a much simpler IDE, and Emacs is working very great for that. So here on the first part, we create 3 points, okay, on 1, 2, 1, 3, and 1, 2. And in fact, the nice thing with the record is that the compiler is going to generate all the getters, the toString, equals, and hashcode methods for us. We don't need to do anything more than just declaring that a point is built on 2 ints called x and y. And I also have a user class. I can show you the user class real quick. The user class is a little more complex. It has just a validation step in the constructor. This is the syntax you have here. Your public user. You don't put any parentheses there. This is the final syntax, at least for the preview release of the records. And within that, let's say, validator, it's not really constructor. It's some code that is going to be added to the construction of the instances of the record. Well, you can add. Here you don't want a null name, and you want an age that has some chance to be an age. So you don't want any negative integers or integers greater than 150. So this is just the 2 validation steps I've put in the user class, well, in the user record. So in the main.java file, I've got some tests on the 2 points, print out just to show you that yes, there is a toString method in this point record. And here, just something on the user record, just something to show you how this validator will be triggered. So let me run that code. I think I already have the runner, which is this one. So if you want to run the code with previews in it, you also need to add this flag -- enable -preview and run the main class, and that's it. By the way, there is a JEP that is specifying both this enable preview and the source flags on the Java-C stuff and on the Java script that is launching that. So let me launch that. Okay, so you can see that the points record has indeed its toString method that just writes point and the two values of x and y. You can see that the equals method is also working, that P1 is not equals to P2, but P1 is equal to P3 in the sense of the equals method. Those are not equals, but the dot equals method that was called. And you see that the first user has been correctly created, James, age 32, but Sarah, with obviously a corrupted age of -10, which is not an age, obviously, has not been created, and we just got an illegal argument exception telling that the age was negative. So this is something that is not in a JDK yet. That was part of the JDK that was just built on this machine. Great. So just as a wrapping up, Tools in Action is much shorter than the deep dive. Just need to be aware of that. You can see that it's not very hard to create your own JDK. It's just several steps to follow, a little methods, and a little planning ahead. If your virtual machine is too small, you will have to stop everything and to enlarge the disks that this virtual machine is using, and probably don't want to do that. You need to be aware of that. It's a little long between the downloading and the compilation. Maybe it will take between 1 hour and 1 hour and a half. So it's not something that you'll be able to do over your coffee break. You need a little more time to do that. You need to make your hands dirty to test new functionalities. Don't always need to do that, because we have an early access version. We have a preview version on the Ember project. We also have an early version on the Valhalla project currently available. So you don't need to do that always, but well, if you want to do it, it's always funny to do. You will be fighting against your IDE, definitely, because of course IDEs are not updated to be able to support those syntax. That will maybe never make it to even to preview releases of the JDK or to early accesses. So don't count on that. For Valhalla, for instance, this public inline class that you may have heard about is not supported by any IDE, and to overcome that, you have another syntax, which is you just put an annotation on your class to declare it as an inline class. But in the following, you can really, but in the end, you can really, first you can put a little badge on your chest saying, I've built my own JDK, which is always nice. And you can also follow what is going on really in real time. That is, follow discussions on the mailing lists to know what's happening, and then build what has been programmed and try it yourself, which is really great. And that saying, I think that's it. Now it's your turn. Good luck in building your own JDK. Have fun with it. I had fun with it, so I hope it will be the same for you. Thank you very much.